So I'll be talking here about how we got going with MetPy, what MetPy is, and go through a lot of the services we use to keep it going with our lazy development staff, which is really mostly myself. So first off, just a real quick background. What is MetPy? So MetPy is a collection of tools for reading, calculating, plotting weather data. So for the meteorologists in the room, this is SKUTs, station plots. We've got support for all our weird data formats. Like on the left, we have Genie files for satellite, and just a collection of these tools together in one package. More importantly, getting things started. So MetPy was started way back when, in probably 2007, while I was in grad school avoiding my PhD. And instead, it kind of withered, and then I started back at Unidata and started to try and resurrect this. And it was, hey, I've got this thing where it's a greenfield project. We can do things right, for whatever right means. And you can see XKCD here, how to write good code. And notice that start project never connects to the end product of good code. So, and the other thing we needed was to maximize what we got for our development effort. We're kind of scraping together hours to put in to try and resurrect this, and so we needed not to be chasing our tail and constantly chasing fixes for things we've broken while implementing other things. So of course the answer is automate all the things. So what does actually that mean? Well, our workflow is everything goes through a GitHub pull request. And so my code goes in through a pull request. Everything that gets added, with the exception of maybe editing the README, goes through a pull request, and that makes sure then all of the automated checks take place. So that means continuous integration, and we'll talk about what that means. But running our tests, making sure the code has consistent style. We also have web services that will do static analysis of the code to try and make sure that we're not putting anything static analysis can detect in Python, which is not an extensive amount, but it helps. And then also having the documentation automatically rebuilt with every commit of code, make sure the documentation is staying up to date, and it actually helps motivate adding good docs if you know it's going to be appearing online. And so this is kind of what it looks like on the GitHub page. I've made some commits here, and then here's a whole list of all these automated checks that are being run because of GitHub hooks are running all these web services. So I've got this quantified code thing. I've got code to see. We'll talk about those. You see these green check marks mean they've passed. And then there are a couple other here that are pending. Surprisingly, there are no red X's here for when something fails currently. And then you can see required statuses must patch before merging. Me as the admin on the repo, I could override this and say, no, I don't care about these. And every now and then, I started off very pure. All of them must pass before I get in, and then things break from time to time outside my control. So at that point, no, just merge the code, get it out of my way. I will fix these checks in a minute, but you got to start somewhere. So you have the big red button you can override at the bottom. But it's a nice set of just all these things must go. And a few of these are required. If you have collaborators, they can't merge the pull request unless certain checks have passed. So continuous integration. For those of you not software engineers in the room, which I'm guessing is probably a sizable percentage here, all that means is that new code is continuously merged in and always checked. Running the tests or running whatever checks you want, but you're just continuously merging new code into your main branch that you're going to make your software releases off of. So one of the services we use is called Travis CI. Travis CI is an online service that integrates very well with GitHub. And when you make a commit to your repository, the GitHub runs hooks, talks to Travis, says, hey, new things have been committed. Travis will check out your repository and run whatever checks you told it to run. And it runs those by default on a 64-bit Ubuntu image. It's also possible to use Travis. They have support for OS X, and you can actually do both OSs out of the same configuration. We don't currently use that because their OS X build chain is it's much slower, and I don't want to be holding it up. And since you can see I use a Mac, I'm pretty confident I'm not breaking the Mac stuff, or at least I'll know pretty quickly if things break on a Mac. So not as important to me for this project. And it also has support for a bunch of different Python versions. So you can create this matrix of run things on Python 2.7, 2.3, or not 2.3, 3.3, 3.5, et cetera. Similarly, there's a service called AppVeyor, and that does the same thing for Windows. And I am not a Windows user anymore, and trying to do things on a VirtualBox machine image on my Mac is just more effort than I can bear, so it's better to have an automated service take care of making things don't break on Windows. And if you don't think there are differences between those two, even without running compiled code, I want to live in your world, because I've hit plenty of things, I've caught things because I have Python code checked on Windows. And these services really, they're good for automating anything. Anything you want to have done on your code, anytime I need to do this to be sure I'm ready to release this software. I need to do this to be sure this code's ready for me to use to write a paper. These services are fantastic. It doesn't have to be necessarily running tests. It can be anything. I've got one of these running that converts our Jupyter notebooks to web pages for hosting online. So it's just a nice service to, I commit code, you go do this for me on your computers, and I don't have to set up any infrastructure locally. And it's free for open source projects. This is kind of what Travis looks like, just at the top level. More importantly, what I want to show here is what the build matrix looks like. And so we've got 12 jobs that run every time I make a commit to MetPy, just on Travis. So for instance, we've got the 3.5 collection here, which runs the tests with coverage. So we measure what test coverage we have, how many percentage of lines are actually executed by our tests. We've got a task that runs the examples. I'll go through more of these in a minute. Linting, so checking the code style for lint. We also have a job on 2.7, do all those as well, so we're covering 3.5 and 2.7. And then we also have a job here that checks our lowest supported versions. So, we have the latest and greatest, but we say, well, we need NumPy 1.9 and Matplotlib 1.4. And so there's a job here that actually checks that and makes sure that those still work. Actually, just recently, we bumped a version because I started running into some problems with older versions. So it's another nice check of, I can be sure that my lowest supported versions actually are the lowest versions that work. And then there are a couple other thrown in here, 3.3 and 3.4, just because I can, and it keeps things, I know, if I need to roll back, throw away like Python 3.3, or, 3.4 has some weird behavior that I need to make sure it keeps working, because we're not getting rid of 3.4 yet. At the bottom, you can also say, here are jobs that are allowed to fail. I want to have them done so I know what's going on. In this case, I've got it running with a 3.5 development snapshot that Travis provides, so that's the next version, the next 3.5 bug release that'll be out. It runs against that. And it also runs like with this flag. I set it up, I say, hey, pass -- pre, that means run with pre-releases of all of my dependencies. So I can run with the latest Matplotlib beta, or I can run with the latest NumPy development release. Same thing here for Python Nightly, which is Travis provided build a Python, and that's 3.6. So you can see I'm already knowing ahead of time, before these releases are actually out, will my code keep working? And you can see by the nice red X here, no, things will not keep working. In this case, I think it's actually Matplotlib's next release, which will change the default styling. It's broken some of our tests, and I'll talk about those in just a second. And then that's what AppVeyor looks like. It's not, it's a different interface, and we don't run as much here. AppVeyor is a little bit slower and doesn't give you as many parallel builds for the open source projects, but we do have checks here running on 32-bit and 64-bit Windows for Python 2 and Python 3. So at least hitting the major points here, and I'll know, have I broken something on Windows? So the tests. We use PyTest, and I found it to be very nice to be able to use that for my testing framework. And when we run the code coverage, so that means track what percentage of lines have been executed during the test. We're running about 94% of that, and that's a number I'm very proud of. I won't say that every test is doing a great job of checking that everything is coming out correctly, but at least I know there are no lurking syntax errors or incompatibilities lurking there. And a lot of those are just older tests that I haven't gone back and tried to be more exhaustive in terms of checking that things are working correctly. And part of those tests also, we run the example notebooks. So all of MetPy's examples ship as Jupyter notebooks. Well, if you use NB-convert utility, we can actually execute those notebooks. So one of the builds on Travis is do the examples, and so it runs every one of those set of example notebooks. We don't check the images that come out, but we can at least say, will the notebooks create any errors when we run them? So it's another keep things working automatically without me needing to periodically go back and do it myself or wait for somebody to scream about it. We also use PyTest MPL. It's a plugin that came out of the SciPy project, and that basically gives us the ability to do image comparison tests. So we have some plotting functions in MetPy, and so using PyTest MPL, we can check that the plots still, keep working the same way. And so make sure we haven't broken anything in MetPy, that makes sure Matplotlib hasn't broken any of our code upstream. And so, instead of just relying on lack of errors, we actually check for pixel by pixel equality or within a threshold to make sure the images still stay the same. And as I pointed out, we run on 2.7, 3.3, 3.4, and 3.5 on Travis as well as the minimum dependencies. And that just makes sure if I say MetPy is going to run on something, it actually runs on it without me needing to constantly do this all on my laptop. And then the Travis nightly versions as well. So that's just so the code coverage, this is what the code.cov.io interface looks like. You kind of get these, you get your big number up here. That's really the one I care about, that 94. And then we have kind of a view you can dive into and see what files have the best coverage, what doesn't, and it also shows you the recent commits, and you can dive in and get an idea. My favorite part of this actually is the fact that there's a Chrome extension, and so on GitHub you can go and look at your files, and you'll get on the GitHub page what lines aren't covered in there. If you're bored and like, okay, I really want to play with that number. I want to see, can I get to 95%? And so you kind of game yourself into, what can I do to improve my test coverage numbers? Oh, this file is only at 3/4 tested. What can I do to fix that? So the code keeps working, but what do we do about documentation? So again, automating everything, we use Sphinx to build our documentation. And if you're not familiar with Sphinx, it's a common Python tool, and its biggest claim to fame, in my opinion, is the fact that you can take your doc strings for your code. You are writing doc strings, right? And it will extract those doc strings from your code and generate restructured text documentation, which you could then turn into HTML. But it will extract all those doc strings and turn those into your API docs. And so at least if you write doc strings, you won't necessarily have great user narrative documentation, but you'll have documentation for what all the functions do available for people to look at. Combined with that, we use read the docs. And what that is that's another one of these online services, and every time we commit to master or other branches, if you set it up, it's going to build the documentation and put them up on a web page automatically. It also provides links for keeping around stable versions. So if you have your .11 release, or for MetPy .2 or .3, we have all those to go back to for stable versions, as well as the nightly latest documentation. And so you can point people to the documentation for a particular version if you need to. And there's a URL. We'll see what it looks like in a second. Over time, I've had some problems with read the docs where, because for building with Sphinx, we don't necessarily install all the dependencies, and for read the docs installing, you can't build any C code, and there aren't Matplotlib packages available, so you can't, if you need to import Matplotlib, it'll break. And so you have to go through this process of mocking things. The important thing here is I gave a talk at a conference that, hey, MetPy has great docs, go to my docs. And then I went to my docs, and they were horribly broken. And that made me very sad. And so now there's another item on my Travis matrix that checks the build of the docs. If there is one warning, it fails the build, and then, again, automatically know, are my docs still good now? And so that's what read the docs kind of looks like. You've got a nice bar over here. You can search the docs, and there's the landing page for MetPy. So we have docs, we have tests, but does the code stay for some value of good? Does it stay good? And so here's an XKCD comic about code style. I know it made the rounds before. It's probably a bit much to have everyone read at the moment. But it's like someone took a transcript of a couple arguing at IKEA and made random edits until it completed without errors. Okay, I'll read a style guide. So code quality and consistency. So we have a couple web services we use for checking code quality. They just do static analysis, maybe see if you've missed some imports, see if you're doing something really stupid that it can figure out, just another nice set of checks. Actually, there are several services out there. Quantified Code and Codacy are the two we've kind of stabilized on. They don't catch everything, and they do produce some spurious messages that, okay, I can fix, but I really wasn't staying up late at night worrying about that. Things like classes, this method of a class should be a static method. I think they do more good than harm, but this is probably my sketchiest part of, do I really like this? And it depends on what day you ask me. We also run Flake 8 on Travis. So that's kind of another one of these static checkers that you can just download from pip and install and run locally. One of the things it does is PEP 8 compliance. So if you're not familiar with PEPs, that's the Python Enhancement Proposal, and this is number 8. Early on, it's the suggestions for standard Python code formatting and style. And this is probably one of those that if you, in a room of Python programmers, who likes PEP 8? Who hates PEP 8? There we go, that's about what I expected. And I'm in the house of, I hate PEP 8, certain things about it. And already for these, I extended the line length because 80 characters just doesn't work for me. But having inconsistent code, especially when you're trying to get contributors from various backgrounds to commit, it's much more important to have a consistent style. Whether or not every last thing about that style is a thing you love, having a consistent one, and Python has one with tools available to check it, is what was important to me. And it's not exhaustive, but we catch some things with these static checks. One more thing about PEP 8 is that early on, I made sure it was entirely PEP 8 compliant and passed clean. So going that from the start, I will never go back and have this gigantic, hey, let's commit 3,000 lines of code to PEP 8 and clean up the code. Because I've seen so many projects go and do that, and then things break, and libraries I've used have broken because of that, and that's a bigger pet peeve of going back and refixing all the code, but doing it from the beginning so that I can make sure we have a consistent style, and anyone can dive in, and the formatting's readable. That was an okay trade-off to me to do from the beginning. So that's what Codacy looks like. Get a dashboard. We have a grade of A. Yay. And then here's quantified code, and it's kind of hard to see. This one's not clean. There's a lot of little issues. I have it for instance, looking at our test classes. I wanted to catch certain things in there, but it telling me that all of my test functions don't have doc strings. I'll add them when I put in new code. I really just am not motivated to go back and add doc strings to all my old test functions. Or for instance, we consider simplifying out-of-bounds check. Avoid unnecessary name repetition. It's good to know about them, but I'm not really motivated to go fix every issue. But it's good when you have new code coming in, we can make sure, have we added any more of these? One last part of the automation suite. So we talked about how code keeps working and stays good. Releases. So we use a library called Versioneer to automatically update the version. And so that is purely looking at our Git repository, and there's a command called git describe. It can start with your current commit and walk back to see what tag is it off of, and how many commits are we past that. And so Versioneer uses that to automatically determine what is our most recent version tag, and so what version of the code are we on. And so if you're doing development, it might be v0.3.0 plus blah, blah, blah. But most importantly, when I make a release and we build the tarballs and upload the Python package index, it'll replace the version with a static one basing purely on whatever Git tag I released. So I don't have to go and make commits to go update this version number in a file somewhere. It just pulls it automatically from Git. Again, laziness, automation. Those are the hallmarks here. So the release process is actually just go to GitHub. They have a web UI for creating a new release of your code. Go in there, create a new tag, type up release notes, and push the button. That gets merged. Travis picks it up. Again, runs through the tests. And then on the 3.5 version, when all the tests pass, it will actually build the tarballs and build wheels and upload those to the Python package index for me. And so it's a one-click, I'm happy, things get uploaded, and I don't have to do anything else. And I don't have to, most importantly, I don't have to remember a release process. I don't have to go document this one-page document of how do I make a release of software. There are many steps. I have those codified for my Travis configuration, and it does that for me. And I don't have to, every 6 months, oh yeah, how do I do that? Just one button. The other side of releases is Conda Packages. And so for Conda Packages, we're on Conda Forge. Phil, I don't see him in here. He will be talking more about this later. It's essentially a community channel for packages with a lot of infrastructure to automatically build packages. And so using that, we have a repository with the Conda recipe for building Conda packages. And again, automatically, you update the recipe and packages are built on OS X, Windows 32 and 64 bits, and 64-bit Linux. Since we're talking about bootstrapping, this isn't really automation since this is about people, but we do have a Giter channel, so that's an IRC-like chat room that's tied to GitHub. You get notifications of issues and pull requests, and you automatically have it associated with the repository. And then we also have the @MetPy Twitter handle, where we put release announcements and we show off some examples that people have submitted. That's what Giter looks like. So in the end, has this worked? Automated checks are very freeing. I don't worry about breaking stuff. I mean, if things break in a release, obviously bugs happen. But if I'm able to release something that's been broken, my tests aren't good enough and I need to fix the test and then the process will save me. And so I don't worry about what I'm going to break that I've already got working. That should stay working. I just need to add new stuff that may or may not be broken. But it'll get better over time and stay working. Documentation's good as, I'm not going to say we have great documentation, but I'm motivated to keep up with the docs because they're automatically on the web and kept up to date. And these things work, we don't have a lot of contributors coming in, but it's been great for sanity checking my own development. And I also, for the contributions we have gotten, these automatic checks really prompt people on their own to go fix things. I don't have to be the bad guy in the pull request saying, oh, well, that thing needs to be fixed for PEP 8 compliance, or that thing, that's not so good. Before I even get to it, the checks have run and said, you need to do this, 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 and this, and I've watched people go and do it on their own without me having to tell them. And that's been really nice. And my last thing is I really, really do hate PEP 8, but I like having consistent code without various styles because I've worked on a project that's 10 years old and Hallie has 6 different styles of Java in there, and that's worse than anything PEP 8 can inflict on me. So there's a few links to useful resources about Travis, read the docs, etc. And one thing I also wanted to say is, so I work for Unidata. We do atmospheric science software development for the meteorology community, and we're hiring a Python developer. So if you're interested, I'll be around after the session, or the URL for the job posting will be at ucarcareers.silkroad.com. And so if you're interested in what I've talked about here or interested in MetPy, working on it, come talk to me or just submit your resume there. Thanks a lot.
Some of the other defaults from PEP 8 and say, like, I don't want to do this particular thing over here instead?
There are a lot of configuration options for Flake 8 there. I think you put them in setup.cfg and there, and you can configure individual checks. That's where laziness really comes in. It's like, all right, fine, I'll just fix the code rather than maintain the list. I actually think I had to turn one of those off recently because they really started getting pedantic. So yeah. So the tests they're running under PyTest. I won't call them unit exhaustively. They are just tests. But no, we absolutely, the 94% test coverage, everything goes in needs to have good coverage. And actually one of the checks with CodeCov for any pull request is at least 80% of the diff has to be covered, and you can't decrease code coverage. So it kind of maintains, if you're submitting stuff, there needs to be good test coverage. Sorry, I can't do anything about it. The CodeCov says you can't commit yet. So. Oh, yeah. I will make this a PDF and put it up it'll go in MetPy's repo on GitHub. Aaron.
How often do you do releases? How do you decide to do releases?
That's a really, really good question that I don't have a firm answer for. We need to release more. I'm going to try to start going to like a quarterly, just cut whatever's been done. I've been trying to use the milestones on GitHub to try and, hey, I'll do this, and then other work happens, and all of a sudden, it's like I need a release, and a third of the milestone's not done yet, or 2/3 of the milestone. So trying to get to probably more time-based releases, but still versioning just point whatever.
You have Travis. You have webhooks for Travis on pull requests. Is that right?
Yeah. And that's baked into GitHub. Basically, you say, it's one of the top level services GitHub interacts with. So that means you can just go to your repo and say, hey, enable Travis here.
And the Sphinx build, you mentioned you can build the docs local. You can build the docs on a commit.
Mm-hmm.
Does that happen on a local commit?
So no, actually, that's read the docs. Will download the repository and build the docs for you. And we could still build them locally. And I'll build them on Travis just to make sure I can get the warnings and check. Read the docs, I can't fail the build. But on Travis, I can fail the pull request if the docs aren't clean.
So there's a webhook for read the docs.
Yes. There's webhooks for CodeCov there, quantified code, Codacy, Travesty. Actually, all of these.
So everything you're doing is through the GitHub.
Right. And so every one of these is a webhook, plus read the docs.
Including Versioneer?
No, Versioneer is just a local script baked into, there's a couple hooks in setup.py. And so all it does is look when you run, when you run setup.py or when you import MetPy. When you import MetPy, it's running Versioneer looking at Git out of GitHub. Or if you install a copy of MetPy or build a release, it's got a static copy of the version file that just has point whatever baked into it by Versioneer. So it overrides some hooks in setup.py to make your tarballs with that. Thank you.
Comment about if you already have a code base that's not clean for Pep8 or MyPlank, you can, this was mentioned already, but you can disable a bunch of rules. So like there are really pedantic ones,
Mm-hmm.
or like if you want to convert the style like piecemeal, like one rule at a time, that's one strategy. There's also a subset of MyPlank rules that are just like straight up bugs. Name errors.
Mm-hmm.
In Python 2, names leaking out of list comprehensions, imports, things that aren't imported, or like imports that override other things.
Yep.
That's like below this attack. So I'd say for any code base, you want to turn on those checks at least, because that will detect bugs that on a human might not necessarily detect looking at a pull request.
Right, so for the recording, so the comment was about there's a lot of things you can do with Flake 8 in terms of configuration to turn off all the pedantic stuff if you want to check at least a older code base, and you can just do things that are outright incorrect. And I don't want to rail on Flake 8. Pep 8 is a thing that's annoying. Flake 8 is a tool that'll do things beyond style checks and trying to do just code correctness checks, and those are ones that you definitely would want to have turned on.
Before you take another question, Brendan, set up while we can continue the questions. I have a question.
Sure.
I saw your test matrix. So you have people developing in the team in different platforms. So you have coverage for OS X, for Linux, for Windows.
Coverage.
Well, the Travis test.
The Travis tests run, and that's really, our Travis tests are just Linux.
Just Linux.
CodeCov will take from multiple platforms, so it will actually aggregate the coverage numbers from @Vayer. So @Vayer will run the coverage as well as Travis, and so we get aggregate numbers across Linux and Windows. As far as the code coverage numbers go, we don't have any OS X specific paths in there.
Okay.
So
Like you set up.
yeah.
So maybe you've had this experience. You can, so the canonical tests are run for Linux, right?
Yeah.
But local developers on, say, an OS X box, the tests will fail sometimes because of library issues. So it's sort of this cognitive dissonance that your developer is failing locally, but then you ship it up and it passes on the Linux.
Yeah,
How
right
do you
now
do
that's
that?
just me on OS X.
Okay.
So I don't do that, but there isn't anything there to stop me. I could add to the Travis matrix. They do have OS X support.
Yeah.
So far, the trade-off hasn't been worth it to me, but that might change in the future. And at that point, we could just use the multi-OS support on Travis, enable OS X.
Any other